Hello everyone, welcome you all to another video on set theory. So in this video we will be looking into the different types of sets. In the previous video we have seen the different representation of sets. So there were two representations we have discussed. One is roster method, another is the set builder method. So in this video we will be looking into the different types of sets. So before discussing upon the different types of sets, we have to be familiar with a term called cardinality. So what is called cardinality? So cardinality of a set is nothing but the total number of elements in a particular set. Total number of elements in a set. So now, for example, we have a set A having elements 3, 6, 9, 10. So the cardinality of A is represented by this or n of A, which is equal to 4. So that means the total number of elements present in a particular set is called cardinality. Now let's move on to the types of set. We will use the term cardinality in our subsequent discussions. So let's first list out the different types of sets and then we will discuss them one by one. So one type is, the first is finite set. Finite set, infinite set, singleton set, null set or void set, which is also called empty set. Next is the equal set, equivalent set, universal set, disjoint set, and another one is overlapping set. So we will look into these different types one by one. So at the very beginning, finite set. Finite set. What do you mean by finite set? The name itself suggests finite set means the elements are finite. There are finite number of elements. For example, let's say M is a set of month of a year, say January, February till December. So the total number of elements of M is fixed. There are 12 elements in the set M. So it is a finite set. Similarly, say set of vowels A, E, I, O, U. So this is a set. This is an example of finite set. So finite set are those sets in which the total number of elements are countable or fixed. So we can say finite set or countable set. Another term that we can use is countable. So finite set or countable set. So finite set, I hope the concept of finite set is clear. Next is the infinite set. So infinite set, it is just the opposite of finite set. As in case of finite set, the total number of elements are countable. You can count the total number of elements. But in infinite set, the total number of elements are not countable. Let's take an example of set n. N is a set of natural number starting from 1 going up to infinity. So the set n is a infinite set. Here the number of elements are not countable. There are many such examples of infinite set. Since the elements are not countable, we can also call it as uncountable set. Uncountable set means the elements can't be counted. So finite set or countable set, infinite set also called uncountable set. So the third category is the singleton set. Singleton set. So the name itself suggests singleton. Singleton means the set will contain only one element, only one, not more than one. Singleton set is a set in which there is only one element. Singleton set is a set in which has only one element. Let's take an example. X is a set having an element 6 only. So in that case we can say that X is a singleton set. So the name itself suggests singleton. So it is single element is there, only a single element is there. Next is the null set, void set or empty set. So what is a null set? The name itself suggests that the set is empty. Null means nothing is there. A set that doesn't contain any element. The set has no element in that set. A set that doesn't contain any element is called null set. This null set is represented by the symbol phi, or we can use the curly bracket without any element in between. So that is null set or void set or empty set. So let's next look into equal set and equivalent set. So there is a difference between equal and equivalent sets. A set, not one set. In case of equal set and equivalent set, we need two sets. So in equal set, two sets are called equal if they have the same elements. If they have the same elements, having same elements, and order of the element doesn't matter. For example, let's take an example A having elements 1, 2, 3, 4. We have another set B, say 3, 4, 2, 1. In that case, we can consider A and B as equal since the elements are same. So we can say A is equal to B. There are two sets A and B. A and B are considered to be equal only if they are having the same elements. So equal set. So that is the example of equal set. Next comes the concept of equivalent set. So what is an equivalent set? Equivalent. Here we will be using the term cardinality, which we have discussed at the very beginning of this lecture. So equivalent set means two sets will be considered equivalent if they have the same number of elements. They should have the same number of elements. Sets having same number of elements. That is, for example, if we consider a set A equal to 1, 2, 3, 4, another set B having elements 6, 9, 4, 5, here the elements of the set are not same, but the total number of elements of A is same as total number of elements in the set B. So we can say the cardinality of A is 4. Similarly, cardinality of B is also 4. Since the total number of elements in A and B are equal, therefore they are considered as equivalent sets. So there is a difference between equal set and equivalent set, and the difference is, in case of equal set, the elements must be same. They can be in any order. However, in case of equivalent sets, the number of elements must be same. So any set which is equivalent, may not be equal. However, any set which is equal should be equivalent. So you have to remember this. If a set is equal, it will be equivalent. However, if a set is equivalent, it does not imply that it is equal. Because equivalent means only the number of elements should be same, but not the elements themselves. So therefore, the equality, that is the difference, basic difference between equal sets and equivalent set. So I hope this equal and equivalent sets are clear. The next type of set is the universal set. Universal set is a set that covers most of the elements. That means, for example, if we consider the set of vowels and set of consonants, then the set of alphabet will become a universal set for them. So all sets become subset of a universal set, and this universal set is represented by U. Universal set is represented by U. So for example, we can say U is equal to 1, 2, 3 up to 10. So then A can be considered as say 2, 3, 4, 5. We consider U as a universal set. A are the elements that belong, A has the elements that belong to the universal set. In other words, we can say that A is a subset of U. All sets are subsets of a universal set. Similarly, you can take another example. Say, let's take a set A containing all the alphabets of the English all the alphabets in English, and V is a set of vowels. So this set V is a subset of set A. So we can say A is a universal set. So that is the concept of universal set. So next set is the disjoint set. Disjoint set means there are some sets which do not have some common element between them. However, there are some sets which have some common element. For example, let's take an example. Say A is a set having elements 2, 3, 4, 5, 9. B is another set having elements 4, 5, 10, 12. So in this case, we see that the elements 4, 5 are common to A as well as to B. So in this case, we can say A and B are overlapping. However, let's take another set, say C, having elements 2, 3, 7, 8. In that case, if we consider B and C, there is no common element between B and C. So in such case, we can consider B and C as disjoint sets. So disjoint means there is no common element between the two sets. However, overlapping sets means there exists at least one common element between the sets. So that is the basic these are the basic types of a set. Along with this, we have another set which is called the power set. Power set. So power set represents a set which is the subset of all the elements of a set. For example, let's take an example for that. For example, there is a set A having elements 1, 2, 3, 4. In that case, the power set of A is represented by PA and contains all the subsets of the set A. For example, 1, 2, 3, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4, 1, 2, 3, 4. and finally the null set. So all these are subsets of the set A. So all the subsets together form the power set, and it depends upon the total number of elements. If the total number of elements, in this case the total number of elements is 4, so n of A is 4, so power set will be having elements 2 to the power 4, that means 16. There should be 16 elements in this power set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 elements in the power set. Let's take an example. Let's take it in general. If a set is having n elements, then the power set, then that set will have a power set having elements 2 to the power n. In other words, if we use the term cardinality here, if the cardinality of A is n, then cardinality of power set of A will be equal to 2 to the power n. So this is very important. So the power set will have cardinality 2 to the power n. So that's about power set. So I hope the types of sets are clear. So there are different types. So in this video we have discussed the different types of sets: finite set, infinite set, singleton set, null set, void set or empty set, equivalent set. Equal set is represented by the symbol equal. However, equivalent set is represented by the symbol this or simply this. Universal set is represented by U, disjoint set, overlapping set, and power set. Power set is represented by P of A. So I hope all these concepts are very much clear. We will make further discussions on this, and these terms will be used across different other domains. So now, based on this discussion, I would like to put a query. The question is, what are the elements in PA for the set A equal to 3, 6, 9, 4, 5. So a set A is given. So what will be the elements in its power set? Also, what will be the cardinality of PA? So I hope the concepts are clear. So I request all of you to respond to this query in the comment box, and in the next video we will learn about the different operations on set, like union, intersection, and there is a different type of representation, that is Venn diagram. So we'll see how those can be used to represent set. So thank you all.